In this video, we'll have a quick look at how to answer addition reaction questions in exams, which require a little more detail and writing than was given in the previous video by LearnCoach. In this question, we have a reaction between propene and dilute acid, which is H2O/H+, which should hopefully recognize as the addition of water. And it produced a mixture of products. And it's mentioning how that there's a major and there's a minor. So this should be hopefully triggering you the Markovnikov's rule, the rich get richer, because that's going to come into this later on. So the first part, we need to draw and name the major products and minor products before we then go on to elaborate. So it's going to explain what's happening on in these reactions, so explaining what the richer gets richer means, explain what addition reactions are. So first step is to draw and name the major and minor products. So we've got to focus our attention here around the alkene or the double bond, and remember that H2O, if we just draw it out like that, we're going to be adding a hydrogen and an OH group. So according to Markovnikov's rule, the carbon with the most hydrogens, which is this one here in the double bond, is going to gain a hydrogen in the major product. So I'm going to draw these out for you, and I'm going to draw them in their full structural formula just so it's clear to see what is happening. And I'm going to use a different color for the water just so you can see. So here we're going to have the H hydrogen and the OH adding in the central carbon. So this one here is of course 3 carbons, so it's prop, and because it's a alcohol, it's propan, and the alcohol's in position 2, it's propan 2-ol. This is our major product. And the minor product is just where we have the other, the hydrogen going to the carbon, which has fewer hydrogens. So quickly sketch that out. Of course, you don't have to do the full structural formula. You can just do the condensed version. So here we go. Now the hydrogens in the central carbon and the OH is here. And this one here is propan 1-ol and is the minor product. Having now drawn the major and minor products, we now turn to the second part of the equation and try to elaborate on the reaction. So it's going to involve explaining what the reaction type is, and also explaining why we're getting 2 products in this reaction. So I would start firstly by addressing what type it is. So here I'm explaining that it's an addition reaction, and then explaining what that is. So double bond being broken and replaced with 2 single bonds. Notice how I'm also referring to what is being replaced. So I'm using this example and specifically to explain an addition reaction, rather than just doing a general explanation. So after I've explained the reaction, then I'll explain why we get 2 products. And the key thing to note is that it is not symmetrical, or it's asymmetrical. The alkene to start off with, it's not in the middle of the molecule. So we are going to get 2 different products when we add water. And when we get 2 products, we're going to get one that's formed in greater amounts than the other. And that's kind of getting to the point why we've got a major and why we've got a minor product existing. But we have to explain how. And this is where you could talk about Markovnikov's rule, but just listing that is not good enough. And it's more important that you can explain what that is. So in my explanation, I don't even mention that, but I do explain what it is. So I explain why that the major product is formed when the carbon of the double bond with the most hydrogen atoms gains another hydrogen atom, whilst the other carbon gains the other group, and in this case that's the OH. The minor product is when this is in reverse, when the carbon with the fewer hydrogens gains the hydrogen. So this explains why we get the minor and the major products to the level that we need to in level 2 chemistry anyway. And I tie it all back together by saying that thus the major product in this reaction is propane 2-ol, propane 1-ol is the minor one. Thus elaborating on this reaction.